Welcome to Cert Bros. In this video we're going to be taking a look at the OSI model. So, what is the OSI model? The model is a theoretical stack of 7 layers that can be used as a reference to help understand how networks operate. The model was introduced to standardize networks in a way that allowed multi-vendor systems. Prior to this, you would only be able to have a one-vendor network because the devices from one vendor couldn't communicate with others. It's worth noting at this point that we don't actually use the OSI model. We use something called the TCP/IP model. The concepts are exactly the same, the layers are slightly different. So if we don't use the OSI model, why would we bother learning it? Well, that's because it's still referenced a lot when troubleshooting or describing network operations. Let's take a look at the layers starting from the bottom up. Layer 1 is the physical layer. The physical layer is the lowest layer of the OSI model. Its key responsibility is to carry the data across physical hardware such as Ethernet cables. Layer 2 is the data link layer. At this layer, the physical addresses are added to the data. This is the source and destination MAC addresses. Switches are located at this layer. The network layer handles IP addressing and routing. At this stage of the OSI model, the source and destination IP address are added. Routers operate on this layer. Layer 4, the transport. The transport layer of the OSI model adds the transport protocols such as TCP and UDP. TCP, for example, is used for error handling and sequencing to ensure no data is lost. This layer also adds the source and destination port numbers. Layer 5, session. This layer is responsible for establishing and terminating connections between devices. Layer 6, presentation. This layer formats the data in a way the receiving application can understand it. This layer is also able to encrypt and decrypt data if needed. Layer 7, application. This layer is where the application and user communicates. Application-specific protocols are used here, such as SMTP, if you're sending an email, for example. A really good way to remember these layers is simply all people seem to need data processing. APSTNDP. So to fully understand how this model works, you need to see a real-world example. Let's say you send an email. The data travels through the OSI model, adding and processing data on each layer. Now this process is called encapsulation. Step 1, the application layer. Outlook creates the data, the email you wrote, the email addresses, etc., etc., and gets ready to send it using SMTP, which is the Simple Mail Transfer Protocol. Step 2, presentation layer. The data is formatted in a way the receiving device will understand. In this example, probably ASCII. This layer could also encrypt the data if needed. Step 3, session layer. A session with a receiving mail server is started. Step 4, transport. This is where it decides to use TCP or UDP. In this case, we'll use TCP to make sure every packet gets delivered. Also, the source and destination port is added to the data. Step 5, network. The IP address of the mail server is added as the destination, and the source IP address is also added to the data. Step 6, data link. The MAC address of the router and the source MAC address of the host is added to the data. Step 7, physical. The data is sent out on the network using Ethernet. So when the data reaches the other side, the receiving device will process the data in the same way but in reverse. starting from the bottom up. Okay, so that's the OSI model. But how can we use this to troubleshoot? You may have heard the term, oh, that's a layer 2 problem, or sounds like a layer 3 issue. When you hear that, that's people referring to this model. Let's say there's a problem with the network. If we go through this model, checking every layer, we can soon diagnose the problem. For example, layer 1, are all the cables plugged in? Is the network card functioning? Could it be a faulty cable? Layer 2, maybe the switch has gone bad. Layer 3, is the router functioning? Do I have the right IP address? And the process goes on and on from there. I hope you've enjoyed this video. If you have, remember to subscribe, comment, and give a thumbs up. Thank you for watching.